Tides are caused by the gravitational pull of the sun and the moon on the waters on the surface of the Earth. Long Island experiences 2 high tides and 2 low tides every day.
Your student's objective is to measure the change in water level due to tides, also known as vertical tide change, at your site. Sites that are not influenced by tides should still test to see if there are any changes, which can be influenced by rain. You will need a pencil, a tape measure, a stopwatch, clipboards, and 2 or 3 long sticks. Alternatively, flag sticks, which are provided in the equipment bins, can be used. First, have a student insert one of your sticks or flags deep into the sediment precisely at the water's edge. Pile stones at the base of the stick if needed to help hold it upright, and then start your stopwatch. After 10 minutes, check the stick. If the water's edge has moved in either direction, plant your second stick at the location of the new water's edge. Make sure not to move the original stick. Now, measure the distance between the original and second stick in centimeters. Enter the distance at the 10-minute mark under the column marked Vertical Tidal Change. Also note whether the tide is rising or falling. Moving the original stick so it now becomes a third stick, continue to measure the tidal change at the 20-minute mark and continue in the same fashion to measure tidal changes at the 30-minute mark. Additionally, make a note as to whether the tide is rising or moving further into shore, falling or moving away from shore, or if it remains unchanged for each measurement. Record all data in your chart and then calculate overall vertical tidal change by noting the distance the tide has changed over the full 30-minute period.
Whereas a tide is the rise and fall of sea level, a current is the directed movement of water influenced by factors like wind, water density, and even tides. So today, your task will be to measure the direction the current is flowing and calculate its speed.
To accomplish this task, you will need a pencil, a calculator, a metric tape measure, several floatable biodegradable objects such as oranges or sticks, clipboards, a stopwatch, and a compass. Have a student throw an orange or stick a good distance out into the waterway to allow the water current to move the object. Observe which direction the object is moving and then use your compass to determine the direction. The current speed is calculated by measuring the distance traveled in a specific duration, in this case, 60 seconds. To calculate this, have one student stand at the water's edge and throw the orange or stick in. A second student should then start a stopwatch and follow the object's movement along the shoreline for 60 seconds and then call out "stop" and then stop walking. Using a metric measuring tape, record the distance between student 1 and student 2 in centimeters. Repeat this process 2 more times at 2 other locations at your site and record all the data in your workbook. Then average the results to get your average current speed. Now, have a student convert the speed reading into knots, which is a unit of speed used in nautical and aviation contexts. There's a helpful conversion chart located in your workbook. There is also a guide how to properly record ebb flow or slack tide readings.
Weather is the current state of atmosphere at a specific place. Your student's next task will be to measure certain aspects of the weather, such as air temperature, cloud cover, and both the speed and direction of wind.
To make these calculations, you will need a pencil, a thermometer, the Beaufort scale included in your workbook, a calculator, clipboards, a digital anemometer to measure wind speed, and a compass. Use your thermometer to record in your workbook the air temperature at your site in both Fahrenheit and Celsius once an hour. Note, if your thermometer does not read both Fahrenheit and Celsius, there's a conversion chart in your workbook. Make sure the location you select is in a shady spot and that your hands are not touching the thermometer tube. It is important to use an air thermometer as opposed to a ground thermometer to collect an accurate reading. Next, look up into the sky and use your best judgment to assess and record whether your site has a cloud cover of 0 to 25% or clear, 25 to 50% or partly cloudy, 50 to 75% or mostly cloudy, or 75 to 100% or overcast. It may help to think of the sky like a grid divided into 4 quadrants. How many of these quadrants contain cloud cover? Your next tasks will be to determine wind direction and speed. First, record wind direction using either the water in the face method or flag method. To use the water in the face method, hold a compass or a compass app in your hand. Spread water on your cheeks on either side of your nose. Face the direction you feel the wind is coming from. When the water evaporates, you'll feel it cooler than the rest of the skin on your face. Ever so slightly, turn your head and stop until both sides feel equally cool. This will indicate that you're facing directly into the wind. Point your compass in that direction and record the direction and degrees. Repeat this test if necessary. To use the flag method, hold one of the flags included in your kit above your head and note the direction that the flag is waving. Using your compass, turn toward the direction the wind is blowing from, opposite the direction your flag is waving, and note this direction in your workbook. Remember, wind direction is the direction wind is blowing from, not to. Next, circle the word in your workbook that best describes the condition of the water. Now, measure and record wind speed using both your digital anemometer and the Beaufort scale in your workbook. Set the units of the digital anemometer to knots or miles per hour, then hold the instrument above your head for approximately 10 seconds to collect an accurate reading. Record the wind speed in your workbook. Using this information, determine which Beaufort force number best describe the wind speed at your site from the Beaufort scale in your workbook.
So remember, these instructional videos are intended to be a supplement for the A Day in the Life program.
Please contact us about our next in-person training, whether you're new to the program
or just looking to refresh your skills.